You know, we spend a lot of time talking about how to build a computer and all that stuff. But you know what we never really talk about? How to prepare for building that computer. So today's video is really directed at you, person who just got your first gaming PC parts for Christmas, or your wife, or your anniversary, or no, not that you got your wife, but let's start over. Today's video is about,
You didn't even say who you were.
I forgot who I am. Hi, I'm JayzTwoCents, and often I teach you guys how to build a computer. But you know what I have failed to do? I have failed to teach you how to prepare to build that computer. So that's what we're gonna do today, with these parts. Never leave home in a hurry and wonder, did I forget to close the garage door? With Wi-Fi enabled LiftMaster garage door openers in the MyQ app. Smart technology and wireless connectivity mean you always know the status of your doors, while the Amazon Key capabilities mean you'll never miss another delivery. To see the full lineup of garage door openers and features from LiftMaster and learn how to get MyQ connected, click the link in the description below. Now, we've showed you plenty of videos and tutorials in the past of how to build a computer, specifically how to build the tower part. But you know, there's some things you can do in preparation and prior to putting everything in your tower that will get you the best results. So we're gonna kind of talk about that today, some of the workflow of testing all your parts, making sure everything works, kind of showing you what the minimal plugins that you need to get all that going. And I'm speaking directly to the first time builder, or maybe someone that hasn't done it in a really long time, or maybe someone that's just never actually done this before. Because these are parts that I actually have to test. These are for a build coming up that you guys probably have not seen by the time this goes live, so I don't want to talk about what build that is, but it is another custom case mod type build, sort of like the Destiny 2, but a whole different video game that we modeled it after. So I have to test these parts, and I don't want to do that with it in the system. So we're going to go ahead and kind of walk through that. Now the parts that we're testing here, I want to see if it'll work with this motherboard. This is 64 gigabytes of G-Skill Trident Z RGB DC. I don't know what the DC part means, but I digress. They're 32 gig sticks, right? These are two 32 gig sticks. Yes, this is a 64 gigabyte kit. So two 32 gigabyte sticks, completely unnecessary, but I haven't gotten these to work in any system I've tried yet. We have got a 3950X, the one that I told you guys that AMD didn't send us. Fortunately, Micro Center was willing to help us out by setting one of these aside so that we can get it, test it, give you our opinions on it. So a huge thank you to Micro Center for sponsoring this CPU. I'll put a link down in the description below where you guys can actually go and check it out, find the nearest Micro Center to you, because I'm telling you right now, if you live near a Micro Center that you can physically go into, you are not going to find better prices than Micro Center. Anyone that's been there knows exactly what I'm talking about. Yes, I'm telling you, the deals, the bundle deals alone are insane. So we've also got the ROG Crosshair 8 Impact. This is that DTX motherboard we kind of did an overview of not that long ago, and I told you I was going to do a build with this, with the 3950X. This was sent over to us by Asus, and basically it's just ITX that's a little bit longer. So there's that. For a graphics card, I'm fairly certain this is what I'm going to stick with. I haven't made a final decision yet, but this is a 2070 Super. Not a 2080 Ti or a 2080 Super or any of that. Not every build I do has to be the toppity top of the tops. This right here is a Revolt Pro from Fantex. This is a power supply that's actually capable of running two motherboards at the same time. I haven't decided if this is the one I'm going to use in the build that this is all going to be going in, but nonetheless, what I'm going to show you today, it doesn't matter what power supply it is. Obviously, it's the process of testing that matters. Now, oftentimes you're going to hear people talk about doing a bench test. So what we're going to do right here is we're going to show you the bare minimum to get the system up and running and booted, and potentially even get Windows installed. If you kind of want to get a head start, oftentimes you can install Windows during this phase as well, so that you are able to kind of be up and running faster once your tower is put together. But we're not going to be doing that today. I'm not even going to be testing any drives today because I don't have any drives to put in this build yet. I still have to source those. But we are only going to need our motherboard out of here. We don't need anything else. We don't need any of the SATA cables out of here, unless you're testing your drive. That's a SATA drive. If you're doing an M.2, you would install your M.2 in there, obviously. And we're just going to take this guy and go boop, right there in the box. It's not that hard, right? There's going to be a lot of debate about whether or not you should put an anti-static bag down and then put it down. But a lot of people would argue too that the bag is designed to stop ESD or electrostatic discharge inside the bag and not the outside. So just put it down on the cardboard unless you want to hear people complain at you because they like to complain. All right, so in preparation of the motherboard, you might notice here I put these clips back on for the sake of demonstration right now. This is going to be specific to AMD. If you're using an Intel CPU, the retention is the same, like for all the different coolers, the hold down is going to be the same. So AMD is known for having two different types. There's a clip type, which has basically a metal bar that will go through the cooler and just clip on either one of these barbs. You can see that these are kind of like little hooks. You'll find that some coolers use the hook style like that, some don't. I'm going to be doing a test right now by just using one of these Wraith style coolers. I don't remember what these are called. I think they're called Wraith. And it's already got pre-applied thermal paste and these screw down screws right here, which screw into the back plate. So to prepare this cooler for its test, or this motherboard, I've got to remove the 4 screws holding down these AMD brackets. But I'm going to leave the back plate on, because if you take a look at it, there's a back plate right here. It's going to be screwing down to that. So depending on the type of cooler that you're using, if you're using an AIO or some sort of an air cooler or whatever, this is going to be the best time to get that all installed. But if you're using a box cooler, and a big, if you've got a box cooler available to you and you've got a big old air cooler that's going in the system, you might want to install the air cooler after the fact, because sometimes they can get in the way of some of the motherboard screws to hold down the motherboard to the actual case. Now, if you're using an AMD CPU, it's actually really, really easy. Be gentle. Pins are located on the CPU itself, where Intel CPUs, the pins are located on the motherboard. So for AMD, you're gonna move this little arm to the side. There's a little tab that holds it down. And then as you move it up, you'll see the entire tray slides. The best way to remember which way this goes, the lettering, at least for Ryzen anyway, will always go horizontal or parallel with the actual socket name right there. So it says socket AM4, and that's where the latch is. See how the Ryzen goes the same direction? That's the easiest way to remember it. Once all the pins are seated, it should go in there without any force, or as like Paul and Kyle like to say, zero insertion force. Push the lever down until it snaps, and now the CPU is installed. So now for our cooler, screw them down. I'll get all 4 threads sort of started, but I won't bottom out the threads until all 4 have started to thread themselves. It just makes it easier. These are spring loaded, so you can just go until they bottom out. So we now have our CPU installed, as well as our cooler. Now, the reason why this is very tutorial-like, where I'm sort of showing you how to install a CPU and stuff, is in the off chance that somebody watching this right now has never built a computer before, and they're kind of going, oh, okay, so that's how you install a CPU. That's how you install an AMD CPU anyway, because that's the one I'm showing here. But this is doing some of the work towards building your system. Because once you're done with this, you're not gonna take this all back apart unless you're using a different cooler, but then your CPU is gonna stay mounted. You don't wanna take the CPU back out if you don't have to. Anytime you remove the CPU, whether it be Intel or AMD, is a chance to bend a pin, and then you're gonna have a bad time if you do that. So you make sure that once it's in, just leave it. There's no point in taking it out. We now have to plug in the fan cable. On this particular motherboard, the CPU fan headers are down there, right above where the DIMM slot is, next to the RAM. On a full-size motherboard, they'll be somewhere along the top. Usually on the top of the motherboard, there'll be printed CPU OPT for optional. So there usually will be 1 or 2. Plug your cooler into that. And now your cooler has power. So the next thing we're gonna do is we're gonna install our RAM. I'm kind of expecting when we test this to get a no post situation, because like I said, I have not found a system that this RAM will actually work in yet. Now when it comes to installing your RAM, you'll notice that there's a notch, and that notch is not perfectly in the middle. That line right there in the heatsink is perfectly in the middle, so you can see how offset it is. You're just gonna line up the notch with the notch that's in the motherboard for the RAM slots. You're gonna put the PCB edges into the groove for the RAM slot. And as long as your notch lines up, it's gonna take a little bit of force, push it down till you get 2 clicks, and that each of the mounting posts, sometimes both sides will flip down, in this case only one did. Make sure it's fully seated, and then you're good to go. And then just do the same thing with however many RAM sticks that you have. Now, this particular motherboard only has 2 DIMM slots, but you'll find your motherboard may have 4, it may have 8, depending on if it's a Threadripper or an X299. You'll want to refer to your manual as to which DIMM slots to use based on how many channel or how many RAM sticks that you have. To do what we're doing now, to make sure that your motherboard and your CPU work, you really only need 1 RAM slot occupied. But in this case, I'm putting both in there because I want to see if this will work or not. Now, if you have an Intel CPU, you could actually boot it up now if you wanted once you plug in power, because Intel CPUs, with the exception of X99 or X299 or any X platform or Xeon, has a GPU inside of the CPU. And if no graphics card is present in the PCI Express slot, by default the BIOS will enable that GPU, which means that you could plug in your HDMI cable or your display port, depending on whichever is on the back of your motherboard, straight into the motherboard and actually get an image on the screen. Because we're using a Ryzen-based CPU, that's not the case, unless it's a 2200G, 2400G, 3200G, or 3400G. Those 4 CPUs do have a GPU in them as well. So we're gonna go ahead and add our graphics card to our little makeshift test bench here. Now this is the part where a lot of people freak out and they go, oh my God, Jay, you're gonna plug it into the PCI Express slot, but you don't have a hold down bracket, which means it's gonna flex and it's gonna break something. That's true if you start like acting like a bull in a china shop and you start flailing around with it, then you could potentially damage the PCI Express port. But we're not gonna do that today because we're not gonna do something stupid. We're just gonna be gentle and easy with it.
For once.
For once, yes. But you see how I have my motherboard on the edge of the box like this? The reason being is typically these 2 tabs are what will snap into the case to kind of support it, and then the slot is held down with the retention tab, and then a screw holding down this bracket. So basically that's 3 points of contact. But for this case, that's not gonna happen. But I've got the motherboard on the edge like that, that way those prongs can hang off the side. But you wanna leave it hanging over the edge like this because if it's pushed up even slightly and some of the pins aren't making contact, you more than likely won't get any sort of a video output from your graphics card. So all we need now to make sure our main components work, and the reason why like I said, I'm not hooking up a drive is not just because I don't have one for this yet, but because it's truly not necessary for this step. The worst part about building a new computer is getting it all in your case and getting it all cable managed and all prettified and zip tied down, and it's just, you're like, I look at my masterpiece, and then you push the button and it power cycles, or it turns itself off after a few seconds, or turns on and right back off. All telltale signs of a pinched wire, or just something is wrong, improperly seated RAM, improperly seated GPU.
Or bad components too.
Yeah, it's happened a few times. Not that many times, honestly. You know, in mass production, there is an acceptable failure rate and DOA on these components. That's considered like, hey, out of so many units shipped, it's expected XYZ of them are gonna be bad. And so what we're testing right now is that none of these are bad. And I have not booted this CPU, or this motherboard, or this graphics card. And I already said I've not got this RAM to work in any system yet. So this is truly a bench test for me, for these parts, to make sure they work before I go through the problem of putting them all into the custom built system we're doing. So I took the 24 pin because this is a fully modular power supply, and I plugged it into the motherboard first and I just left it kind of dangling there. Next, I'm going to take my 8-pin CPU power, or in this case, PCI Express power, and we're going to plug it into the graphics card. That's a 6-pin, and we got an 8-pin for the 2070 Super. And then this is our 8-pin power. It's got electrical tape on it because the last build I had it in, I got tired of these separating while I was trying to plug them in, so I taped them together. That is going to go into our 8-pin power right there. That's all we need to actually get this system up and running. I don't have to make any jumper of pins on the motherboard to get this system to boot up because it has surface power. There's a start button right there. It's got a surface button. So when I push that, that's the same as a power button. With the exception of storage, that's a computer. That's a fully working computer, theoretically. We haven't booted it yet. So now is where you're gonna take your monitor, if you've got one, or even a TV will work if you're building this in your living room or something. Run an HDMI cable to your graphics card, or in this case, we're gonna be running DisplayPort. So we'll plug this in. We have to plug in power for our power supply. This particular power supply has a toggle switch for power to turn on and off, like from this cable. So I always turn that off before I plug it in. Then I turn it on. And the first thing I'm looking for is if I get any lights on the motherboard. And as you can see, I do have RGB lights that are illuminating on the side, because this particular motherboard does have passive lighting that turns on when the system is off. Power supply is on. We are now ready to see if we get a post. I really don't know if we're gonna get an image. 1914 CC 92 C8 63. What I'm reading are the codes on the back. It's a normal reboot. That happens when it first does its boot. It trains memory and then it restarts. That,
the RAM lit up.
Yeah, the RAM lit up, but it didn't come back on. This is why we bench test, because we want to do any troubleshooting we get at the start rather than later. See, nothing happens now. So I'm gonna go ahead and do a clear Cmos. Now Cmos clear is gonna be dependent on your motherboard. Fortunately on the Asus board I have here, there's a button on the back. So because I pushed that and held it, everything shut off. It's clearing all of the BIOS and resetting everything. When I let go, everything lights back up. So you can see the QR code, or the Q code, that's telling me what stage we're in on the post or self-test, and it turned right back off and did the same thing. I'm gonna suspect right now, because it's doing that, I'm gonna turn off my power supply, and I suspect what's happening here is it's that memory. So because I have extra memory, I'm gonna change those DIMMs, power back on. .63, so that just passed memory. It's doing its restart. Well, that's not a good sign. Do we have bad motherboard? I'm kind of glad this happened, to be honest. This is exactly why you do this. The worst time to deal with this and the most frustrating time is when your system is all put together and you're just like, yeah, I get to play games now. Then this happens. I'm gonna undo the graphics card, but Jay, it won't work without graphics. I know, but I wanna see if our boot issue stops if I take the graphics card out. If it will then just boot and give me a QR code of like, hey, no graphics, then we might know that that's the problem. We switched the memories. We switched the memories, so we know it's not that. Yeah, just turn itself off again. Might be CPU related. That would be sucky. That's the deepest thing we installed, right? That would be the worst thing to...
But again, imagine if you plumbed this into a loop or something.
Oh man, don't even, yeah, stop it. All right, so the problem persists with this graphics card unplugged, so I'm gonna say that this is probably fine. What I'm gonna go ahead and do now is check the CPU. So it just dawned on us that we're using an X570 motherboard with the 3950X, where the motherboard was sent to us long before the 3950X was launched. So we think we might be having a BIOS issue here. So I'm loading up a 3600X, which I happen to have, which realistically nobody else going through this is going to have. But fortunately, this motherboard does also have a BIOS flashback feature where if you find yourself in this situation, you would be able to update the BIOS without even having a CPU installed. One more try. Yeah, see, that shutdown. That shutdown is what's worrying me. Two different CPUs. Without the motherboard, still shuts down, different RAM. The only common denominator in this is the motherboard. Why don't we try the BIOS flashback first? What do you say? All right, so I just went to my desktop, downloaded the latest BIOS for this motherboard, which is quite a bit newer than the one on here, I'm assuming, just because the BIOS is actually written on the box, which BIOS it ships with. So this is only a couple weeks old, actually. Now on the Asus motherboards, you'll see that there's a white box around one of the USB super speed ports that says BIOS. That's the one you're gonna put the card into. When you download the file, it's gonna have a file and then it's gonna have another like little application called BIOS Renamer. And when you click that, it's gonna rename the BIOS to the file name that this motherboard is looking for to say, hey, that's the BIOS, I'm gonna replace it with that. All you do now is you hold down the BIOS, looks like a reset button, it's got little swoopy arrows. You're gonna hold that down until it starts to blink and then let go. When it's done blinking, the BIOS flashback is done. Now you can do this without a motherboard. No, you need a motherboard. You can do this without a CPU, without memory, and without a graphics card. You just need the motherboard and the power hooked up to it. So it was blinking for about 5 minutes, which it says is normal. So I'm gonna go ahead and I'm just gonna power cycle the whole motherboard. Power off, power on. And let's see if that made a difference. If it does its power down, see, it's the powering down that has me concerned, because normally whenever I have BIOS problems, it just hangs. It doesn't shut down and then all the buttons lock up. So this was a, it did it faster. Clear CMOS one last time. If this doesn't work, then we'll switch the motherboard out. Yeah, see, it just, the way it just clicks off. And it's doing that with a different CPU. All right, here's what we're gonna do. Everything you just saw me do, with another motherboard. All right, so we're back to where we were, only we're on a full-size Crosshair 8 board. This is a Crosshair 8 Hero. Let's see if it gives us a picture. This is also the 3600X, not the 3950X, because I want to see. All right, so we just got past the point we were. Oh yeah, we're gonna get a video right now.
No, it shouldn't, because you don't have anything plugged in.
Oh yeah, you're right. 92, there, see, right there. So we're not done yet though. We got one more thing to do, and that's to see if the 3950X will work on this BIOS out of the box. It's 50-50 at this point because, no, it's 3950. Well, it's just because I know I've had this motherboard since before the 3950X was out. 9C, 92, A2, D7, now we'll get, there it is. So, unfortunately our DTX, whoa, almost fell over. Unfortunately our DTX board broke. That's why you test bench stuff, or bench test stuff.
Test bench stuff.
That's why you bench test your stuff before you put it in your system. So I just took you guys along for the ride for something I had to do anyways. You'll see it in build guides and stuff if we fail to mention like testing it on the cardboard box, whatever like this. A lot of people, veteran builders and stuff will be like, oh my God, you need to teach newbies, they need to test it first. Because you just saw, we went through troubleshooting. Okay, we took the graphics card out, it's still powered cycled. Switched the RAM, switched the CPU, all the same stuff. With the exception of switching out the PSU, which in my case I knew worked. If it was a bad PSU, if you want to know the truth, usually what will happen is it'll click off right away, or not power on at all. So in this instance, the only thing left after updating the BIOS on this board was still the board. So I'll be reaching out to ASUS asking for a replacement board for this because I do need it for a build that we're doing. This wasn't just for the sake of the video. This was me legitimately testing this stuff, and you guys got to see what happens when something goes wrong. Thank God. Hey, Phil, we actually did something and taught someone something.
For real.
It just sucks now. I gotta wait for a new motherboard, and it's gonna take till after the holidays. I can still continue with the build because there's lots of modifying and stuff to the case we got to do that doesn't require that to be in there. In fact, it shouldn't be in there when I'm cutting and let's just say using fire in this one.
Spoiler alert.
Test your stuff, guys. It's a lot easier when it's like this than when it's in a system, especially if it were plumbed in like that.
Yeah.
If I hadn't tested that stuff first, then oh, that would have been terrible. All right, guys. Thanks for watching. Happy holidays. I hope you guys got all the PC parts you hoped you got for Christmas. And if you didn't get those parts, well, go steal them. I don't know. Maybe don't do that. That's bad. I can't say that. Go donate plasma. I don't know. Sperm bank, whatever. Make money.